Hello, welcome back to another gas walkthrough. Today we are solving Philip Newman's serial numbers. Philip Newman is one of our setters here at Gas HQ. My name is Bill Murphy. Normally I would have posted yesterday, but I fell asleep. So apologies. That is the honest to God actual truth. I went to bed and just forgot to post anything. So apologies to Philip and Clover, who were worried about me in my absence. As my karmic retribution, I get to solve a Philip Newman puzzle, who has been griefing me all month with puzzles like this. This one's alright. This one, I can at least explain all the steps. Normally, I'm also solving Clover puzzles, but, Clover will be back tomorrow with one of mine. At Gas HQ, we are genuinely approachable Sudoku. We set genuinely approachable Sudokus for, your average person to solve. This one's slightly on the trickier side, as what I'm going to assume will be a slightly longer video. Now, give this puzzle a go. It's a good puzzle. You'll find the link to it in the description. And you'll also find some hat times. 2 hats is for a very fast time. 1 hat is for a pretty fast time. And everyone gets a dinosaur because we love you all equally. With that, let's get into the puzzle. Sorry, my dog is just pacing around the house, trying to be like, oh, I want to get on the couch next to Dada, but he's talking, to the laptop, so I don't want to bother him. But it's Betty. She is a sweetheart, and she would never bother anyone. Okay, let's get into it. This puzzle is called Serial Numbers. It is a killer Renban puzzle. So, each normal Sudoku rules apply. So, each box, each row, and each column must contain the digits 1 to 9 once each. Now, killer cages. Digits in cages cannot repeat and must sum to the total given. And the purple lines are Renban lines. So, digits along these lines must form a non-repeating consecutive set in any order. For example, a 4-cell Renban line could be 5, 3, 4, 2. Because, 2, 3, 4, 5 are all consecutive. As you can see, I've got the killer cage thing up today because that's going to help us a lot. It could be anyway, but we can't have 5, 6, 7, 9 because we need 4 consecutive numbers. With that, let's get into this puzzle. Now, I'm going to leave this... I'm going to leave the killer cage calculator up, not because I can't do the math in my head, but because we need these puzzles to be approachable, and we want to make this a good walkthrough for you. So, 6 in 3 cells can only be 1, 2, 3. 7 in 3 cells can only be 1, 2, 4. And because we know that 1 and 2 must be in these cells, this has to be 1, 2, and 6, because we need to put 1 and 2 in row 3. Now, Renban lines must have a non-repeating consecutive set, meaning that these digits... Betty, come on, couch! Alright. These digits cannot repeat along a line. So, because I have 1, 2, 4 here, it means that this cannot be 1 or 2, otherwise a digit would repeat. So let's put 3 in there, get these out. Because I have 1 and 2 already here, this must be 6. And, pardon me. And 1, 2, 3, 4, 6 means that I need to put a 5 here. We can do a little bit more with this. Now, I know that I need to put, because this is 1 or 2, this needs to either have, either be 1, 2, 3, 4, or 2, 3, 4, 5. Now, there's a couple different perspectives you can use to look at it. Oh, hang on, I feel like a dog's about to get on the couch. There we go, there's a Betty girl. All right. Now, there's a couple different perspectives you can look at it. I'm going to teach you both ways here. So, the one that I don't use, but you could if you chose, is I would need to put, so if this was 1, this would need to be 2, 3, 4. 2 plus 3 plus 4 is 9, which is not 12. So we know it's not that. The other way that you could choose to look at this is if this is if this is either 1, 2, 3, 4 or 2, 3, 4, 5, then it means that along this line I must put a 3 and a 4. Because I can't put a 3 there because we already have a 3 in box 1, I need to put a 3 here. 3 plus 4 is 7, meaning I need to put a 5 here. So this is 4 and 5. Because I have 4 already in this cage, I know where it goes in row 2. It means it cannot go there, it must go like that. Now, 3, 4, 5 means that this must be 2 and this must be 1. We're still not done up in this area of the puzzle. 6, 7, 8, 9 go here. Let's ask ourselves, how long is this line? It's always a good thing to check. So because it has a 1, it can have 1, 2, 3, 4, 5, and 6 along it in any particular order. But that means that this cell must always be 6, because if it was 7 or higher, we couldn't have a consecutive set. So this means that we need to put, this becomes 6, 7, 9. And now these cells need to be 2, 3, 4, and 5. Can't quite do all of that just yet, but we will be able to come back to it in a little bit. Let's go down here where we are blessed enough that the symmetry works. 7, 8, 9 is how we go for the 24 cage. 6, 8, 9, and this 21 cage must contain 8 and 9, and as you can see up there, if you can't do the math in your head, 4, 8, 9 makes 21. Now we can take the 4 out of here, but 6, 8, and 9 means that this cell must be 4. 6, 8, 9 over here means that this cell must be 7. So we can take that out of there. 4, 6, 8, 9 means that this cell needs to have a 5 in it. Now, we can do the same logic with the 16 cage. If this was 9, this would have to be 6, 7, and 8, which is 21. So we're going to put an 8 in there, put a 9 there. But because this can't have an 8 and it must be a Renban line, it means this must be 5, 6, 7. The 6 here tells us which way this goes. This is 6, this is 5. This 9 cell Renban must be 6 long, so it must be 4, 5, 6, 7, 8, 9. The only cell that can go there is 4, meaning this is a 1, 3 pair. And oh yes, we can do this cell. This cell's a 2. Why is it a 2? Because this Renban line can have only 1 to 6, meaning this is what it can't be 1, 3, 6, 4, or 5. So that must be a 2. And similarly, this cell needs to see 4, 5, 6, 7. This cell sees 4, 7, 6, 5, and 9. So that's an 8. I can now put a 2 in this in column 7. I can put it there because I know where it goes in row 3, so it can't go down here. So this is 2. This is 5 and 9. 5 and 9. That 5 tells which way around this goes, 9 and 5. But I'll take the 9 out of there. Similarly, we can do this trick down here, but I'm going to finish this little bit off first. We can place a 7 and an 8 in there, and a 3 and a 4. We know which way around they go because of the 3 and the 4 there. So this is 3, this is 4. Now, as you can see, 7 and 8 make 15. So that's how that goes. This is 6 and 9. This is 5, 6, and 7. We can do a little bit with this. So we know which tells us which way around these go. I can actually place the 6. That's a good idea. I should do that. We'll take the 7 out of this one. 8 and 7 and 8. 7, 9, 7, 8, 9 and 8. Oh, pardon me, my eyes just become very itchy. Let's go down here and let's finish this edge of the grid off. 8 over here can't go in these cells, so this is 8, meaning this has to be 5 and 1. 2 and 3 can't go in those cells because we've got a 2 and a 3 there, meaning this is 2 and 3. Now, to make 10, we need to, if this is 2, this becomes 3. If this is 3, this becomes 2. So this is 6, and this is 1, 4, and this is 7. All right, now we're almost through this puzzle. But we should probably do a little bit more here. This is 3, 4, 5. 6 and 4 go like that. We can take the 3 out of here and resolve that, making this a 1 and then a 2, 4. This is 3, 5, and 7. And this is also 3, 5, and 7. 1, 2, and 3 to place here. Uh, 1 and 9 to place here. And 4 and 6 to place here. We can do that because we have a 4 there and a 6 there. Now, there is a bit of logic here that I can do, which I'm going to do it in a second. But I do want to point out, I know Philip Newman. I know what GSP is. A lot of my puzzles are rotationally symmetrical. I could just put a 5 in here if I was cheating. If I was doing multiple Philip puzzles in a row for testing, I would just cheat and put a 5 in here. I'm not going to do that. I will show you a way that you can figure this out on your own. Now, this cage here, well, we already know that it can't have 6 or 8 in it. And why can't I have 5? So, okay, hang on. I'll back this up. That was for me. Sorry, I did this puzzle earlier. So this cage can't have 6 or 8 in it with the cage calculator, and because I need to put a 2 and a 4 here, it couldn't be 2, 4, 5 because that would leave that cell with no candidates. So it must be 1, 3, 7. As shown above. Another way that you could choose to look at it, if you want to, is if I put a 5 here, 5 and 7 is 12, which is bigger than 11. Similarly, if I put a 7 here, this becomes 5, which is bigger than 12. Also, it leaves no candidates down there. So, the only way... Oh, sorry, don't mind me, I'm very slow. I've just noticed the pair myself. But that is a way that you can always test killer cage combinations by figuring out what's the biggest possible thing that you can have. As soon as you go, as soon as you go, hey, some of these are maximums, some of these are minimums, yeah, you're fine. All right, 3, 5, 7. This is a 1, which helps me do all of these. 9 and 1. 8 and 9 to place here, but 7 and 3 is 10, meaning I can put a 9 there. 6, 9, 8, 6, 4, and 1. 2, 4, and now we have just finished the puzzle. This has been Serial Numbers by Philip Newman. My name is still Bill Murphy, last time I checked. I hope wherever you are in the world, you have a fantastic day. I will catch you next time. Hopefully, I will not sleep. Bye.